Thank you all for joining the webinar on Treatabolome today, and it's really our pleasure to present the first version of the Treatabolome database. So I'm Leslie Matalonga, I'm Clinical Genomics Manager at the Centro Nacional de Análisis Genómico, the CINAG in Barcelona. And together with Alberto Colbó, a software engineer leading the development of the Treatabolome database, we will be presenting today this webinar. So please feel free during the webinar to add your questions in the chat. I know that Giselle Bon, Sergi Beltran, and I guess also Antonio Talaya are here, which you will see are the core people involved, among others, in the Treatabolome initiative. So at the end, we will also have time for questions and discussions. So the Treatabolome initiative has been created in the context of rare diseases. And as you might know, 7% of the population is affected by one of the around 5,000 to 7,000 rare diseases clinically described, meaning that there are around 30 million people in Europe suffering from one of those, and 70–80% are of genetic origin. Unfortunately, to get to this clinical diagnosis, to this molecular diagnosis, the patients have to go through what we call the diagnostic odyssey, and they have to visit many specialists, hospitals, get many tests, and the meantime actually to reach a final diagnosis is of almost 5 years. And this is why IRDIR, the International Rare Disease Research Consortium, set up the goal for 2027 to enable people living with a rare disease to receive not only an accurate diagnosis, a clinical or molecular diagnosis, but also an available therapy within the first year after coming to medical attention. And this means that apart from reducing this diagnostic odyssey, we really need to work towards not having a second odyssey for having access to available treatments. And aligned with this goal is the Solvardi project, from where the Treatabolome database is funded and has been developed. So Solvardi is created for solving the unsolved rare diseases, and this is a European-funded project with more than 200 groups involved in Europe and putting together expertise not only from clinicians from different European reference networks, but also geneticists and major infrastructures such as RDConnect, or these involved too. So the major aim of the project, as I mentioned, is to solve unsolved cases, meaning cases that have gone through a regular diagnosis pathway in different countries and have remained unsolved. And for that, we are reanalyzing more than 90,000 exomes and genomes, and also generating other types of omic data and funding several projects to study and validate possible new disease-causing genes. But apart from this diagnostic point of view, which is of course essential here, the project also aims to go beyond and link the diagnosis with the therapy, and this is why there is a specific dedicated work package and working group led by Giselle Bon on this regard. And the idea here is to enable the patient that we can diagnose in the project, but also, of course, outside the project. This goes beyond Solvardi, that can be maybe identified by non-expert in a specific disorder, but really to have a quick way to identify if there is an existing treatment for that disorder, and if so, which one. So the Treatabolome initiative builds on previous work that was done by Rachel Thompson et al. on performing a systematic literature review to find all the evidences for pharmacological treatment for congenital myasthenic syndrome. And they work here gathering evidence from more than 200 studies and over 1,000 patients that were stratified also by the genetic origin. And this work really aims to be the foundation for computer-aided systems to enable the clinicians to gain an easy access to this information, to which disorders are treatable, and if there are specific variants or gene evidences to be considered. So from there and within Solvd, the Treatabolome working group worked into providing a template that would include the instructions for writing these systematic reviews in a fair way, in a findable and accessible, interoperable and reusable way. And the final idea was to feed what was already envisioned as this Treatabolome database that we'll be presenting today. And this way, disease gene treatment information would be easily or more easily findable in a centralized place, not only for clinicians to access the data, as we mentioned, but also to be integrated in other systems, such as analysis platforms or decision support tools that can already provide this information and integrate that. So based on these specifications that were published by Antonio Atalaya et al., several disease experts have worked together to create these systematic literature reviews on different disorders. And indeed, there are 6 different systematic literature reviews that were published in a special issue in the Journal of Neuromuscular Diseases last year in May 2021. And as we mentioned, so here we have all the information compiled, and this is a tremendous effort that was done by these clinicians, but we then have a real need to have all this in a central database to make it accessible and interoperable. So now I will give the floor to Alberto, who has been leading the development of the platform, that will explain you a little bit more on the database and how it works, and then we will go finally for the demo.
Okay, thanks Leslie, and thanks everyone for joining from my side. In this couple of slides, I will briefly discuss and I will discuss what the Treatabolome database is, how it was designed and implemented, and also what includes at the moment. What you see on the screen is the homepage of this web portal that you can access with the URL that you see on the slide. And the Treatabolome is, as Leslie was illustrating, a gene and variant-centric database of treatments for rare diseases. So this is a web interface tool that allows human access to all the data that was recorded with the systematic literature reviews in a tremendous effort from experts and clinicians. In this homepage, you can access directly the data portal that is now publicly available, and you can start querying these results that were collected in these years. In more detail, the Treatabolome database was envisioned to include 2 main feeding sources. In the first one is, as we said, the systematic literature reviews, and this was the first phase of the project in which 7 systematic literature reviews were conducted, and the data sources collected together to provide the first layer of knowledge of the database. Also, we have an external systematic literature reviews that we know is now currently conducted on monogenic bowel disease, and another systematic literature review on late syndrome that it's also included in the database. The second phase of the project, and this is a spoiler on the future development, will require to develop, identify and develop a crowdsourcing approach for gene treatment and variant treatment panel evaluation, similar as the example provided already and widely used by the panel app from Genomics England. So, as Leslie was mentioning already, the Treatabolome database includes the systematic literature reviews, and all the records of these reviews were checked internally by our engineering team at SENAG, and then the data made available in the web portal. As I said before, the ataxia systematic literature reviews is now ongoing and will be also added there as a source of knowledge on the database. So a few details on the data granularity of the Treatabolome database. When the project started, we developed together with the Treatabolome core group template which all these records could be put together and collected, and every row was representing a piece of information on disease, gene variant, and treatment association. In the level of detail, we have then information about the publication linked to this trio. Then the clinical information using standards as ORDO, ORFA codes, OMIMs, HPOs. Then information about the evidence that is provided in each publication and each study conducted. Gene and variant information, also relying on well-known databases such as the human gene ontology, the reference sequence ontology, and so on. And also information about inheritance and more in detail variant and protein. At the end, we have also information clearly on treatments. So here we're using mostly two databases, MESH and KB, to encode and standardize the information on the treatments, plus information on clinical effects, biomarkers, and negative effects. In some numbers, then we have now in the database more than 3,600 entries with 1,192 different variants, more than 700 publications, 77 genes that then can be linked to actionability from other platforms, and Leslie will show it in a minute, such as the RD-Connect app or other genomics applications. And then 180 different treatments. So this is already a good start as a database, and of course we hope that these numbers will keep increasing in the next years. Just a few details on the technical aspect of the Treatabolome databases. So as I said, we envision as including two different sort of inputs, so systematic literature reviews and crowdsourcing intervention from clinicians and experts to validate the entries of this database, with two different processes involved. So a semi-automatic validation that of course would hope to be fully automatic, but that's never the case, to really clear the data and make everything homogeneous. And on the other side, then a step from the community, carried by the community, to address the crowdsourcing approach. We have behind a relational database and a web portal that guarantees human access to this data. Of course, we are also working on providing an API that would give the chance to programmatic queries from other parties, the RD-Connect app in our case, but also other genomics applications that are interested in this platform. To design the web portal, we start with experts and clinicians and the Treatabolome core group conducting several sessions to collect all the requirements, to be sure that all interesting use cases could be supported in a flexible and user-friendly way. The three main requirements that we can identify here are facilitating database interrogation by filtering by ORFA, OMIM, gene variants. Then a strong focus on treatments and the associated evidence, easy to navigate, easy to redirect then to the specific PubMed or documentation. and then to support presentation and summarization of treatments in an intuitive way to explore and query the data in a clear way. And we did, of course, different versions, and Leslie will show it in more detail on how it's working in a wall. The web portal, then we can say it's will look like this. So just to familiarize a bit with its look, it consists of two main areas that you will see on the screen. The search panel on the left, where users can filter and see results in an aggregated way to simply navigate the entries. And then in the center of the screen, the treatment results that are grouped by gene, organized by cards of information that will appear in a scrollable list. So every treatment evidence is displayed in a card with the information regarding the evidence, the publication, number of patients that were included in each study, and then a list of variants associated to each entry. I think that now Leslie will show some clinical use cases that will help you to understand how this can be useful in your work, in your research, and in general for the whole domain.
Okay, so before starting the actual demo and examples in the database, we just wanted to illustrate a little bit the usefulness of this type of approach, and this is preliminary results from SolveRD. So as I explained before, we are currently reanalyzing thousands of cases from different European reference networks in SolveRD, meaning that we really have different types of disorders, and maybe non-experts in the field are also looking at the genomic data. So from the preliminary results on the first 509 cases that were solved, we tried to identify how many cases would already benefit from treatments reported in the Treatabolome database, but also in other initiatives that we know exist, such as ClinGen actionable genes or the EMBase for metabolic disorders. So despite we know that many rare diseases do not have yet a treatment, and with the limitation that for now the Treatabolome is mainly fed by neuromuscular diseases, we saw that 12% of the cases, which are 61 families, would have a causative variant in a gene that is potentially actionable, or at least have a treatment reference. And if we look into the different databases, we can see that 27 of these families were identified, the causative gene was identified in Treatabolome, so we would have information there on which it's the treatment that exists. And from those, 22 were unique from the Treatabolome database and not present in the other one. So this is also to illustrate that we need to cooperate as we are all tackling different types of disorders. So now I will go for the proper demo. Okay, so before, yeah, I wanted to show you another one, but I won't make full screen, otherwise I have to switch. So these are the approaches that we want to show you during the demo. So we'll see different clinical scenarios. The first one would be once you have identified a causative variant in a specific gene, and we'll see how you can look for treatment options from there. Then we have another use case, which would be once you have a clinical diagnosis and maybe you want to have an overview of the treatment available for that type of disorder and which genes are involved. And finally, we are going to show an example on how this kind of database can be integrated in an analysis platform, and we will be using the Reconnect genome phenome analysis platform to illustrate that. So this is the Treatabolome landing page, as Alberto was showing in the slides. So here you could find more information about what is it and who has collaborated for now for this initiative. And once you access the data portal, you have different ways of starting to browse the database. So as we mentioned, the first use case would be if we identify a causative variant in a specific gene. So it's a coenzyme Q deficiency, and I will be using COC2 to illustrate. This is like a simple example. We'll go in more complex one later, but just for you. So you would enter the gene of interest, and then here is the result on the Treatabolome database. So as Alberto was mentioning before, on the left, you will have different ways that we will be seeing to filter a little bit more the data or to play more with the data. And on the right panel, what you will have is the result on the treatments that are associated to either the disease or the gene you are looking for. So in this case, we have selected the COC2 gene, and there is one treatment described available in the Treatabolome database, which is coenzyme Q10. And here you can see the list of publications that support this gene treatment association. And moreover, in each of these publications that you can link out to have more details on the study and the paper for all the specific information, you can also see if there are specific variants described associated to that treatment, and you have the genotypes of the patient or patients involved. You have information of the number of patients that are in each of the studies, the year when the study was overcome, and this is sometimes helpful if you see it's an old publication or a recent one, the diagnosis associated with the gene and the treatment, and the evidence, the Oxford evidence score that will help you also to know which type of study supports this gene disease treatment association. Here on the right, if you click on the view icon, you can have much more information and link out, for example, for the specific disorder to Orphanet or MIM, but also to the specific drug with, for example, going to KEBI, where you can see a description of that specific drug reported. You will also have maybe comments from the people, the experts that have entered this gene disease association, and clinical effect evidence, if there are negative effects associated, etc. And on the genomic side, you will also see here specifically variants that, if reported, have been reported in that study. So this is like a quite straightforward case, and now we'll go for a little bit more complicated one. So here on the top, you can clear your search, and I will go for causative variant in the LMNA gene, which in our case would be associated with the familial dilated cardiomyopathy. When I select this gene, in this case, it's not as before, where we only had one disease and treatment associated, but we can see that here we have 189 different associations. So if I click here, I have the associations ordered by the Orpha, so the Orphanet clinical disorders. In our case, we were in a case that we know has been clinically classified with a familial dilated cardiomyopathy, so I could go directly and filter my data by only the association reported to this clinical disorder. So on the right, I will get these 112 evidences and variant association, and the list of treatments as we showed before with the same information. It gives you information on the number of treatments. So here we have 9 different treatments associated to this gene and this clinical presentation. And it also gives you information on which one is the most frequent, or the most reported. In this case, it's the implantable cardioverter defibrillator. So again, you can browse this information. Yeah. Okay, and in this case, if I had, for example, a variant of interest, I could, because maybe I don't really know which one to start with or which treatment to really look into, I can also try to search here on the left in the search boxes if the variant that my patient has been reported somehow in the database. So here I will enter one variant, which we can imagine is the one from my case. So at this cDNA position, and we do the search. And in this case, we see that this variant has been reported in this specific study, which treatment was the implantable cardioverter defibrillator. So I can have also, as we mentioned, more information, and I can go to the publication to see exactly how that patient answered to that treatment, to decide what to do with my own patient and what decisions to take. So these were examples at the gene level. And now I would like to show you one at the disease level. So if you have a clinical diagnosis and you want to see which treatments are available in this type of database. So I will clear the search again. And here I will enter a disorder, so the late syndrome. So let's imagine that we have a patient clinically diagnosed with late syndrome. And what I can see is that there are several genes involved with this disorder. So if I want to see all the treatments associated, I will click here to all, and I will see that there are 3 different treatments. And then I can go gene by gene if I'm interested in one of those to see the different treatments associated. But apart from that, I can also decide to filter my data by treatment. So instead of having the genes, because I might not know the molecular cause of my disorder, I can just go and see and filter it by treatments. So I would select the ORFA, so the disease, and then the treatments that are available for that disorder. And here is where you can play a lot with the data and decide a little bit how you would like to get the results. So in this case, for late syndrome, I can see that these are the different treatments. And if I go for the one that is more frequent, I would go to this EP743, and again have more information, and also can see the genes that are involved or reported associated to this disease and this specific treatment. Again, maybe if I want to see if this treatment has been used for any other type of disorders, I could browse by a specific treatment. So here, if I take this one, I clear my query. I could also make a search in the whole database to see which clinical entities or which genes are associated to this treatment. And here I can see that apart from late syndrome, you also have this treatment that is used for Alpers-Huttenlocher syndrome. And again, you can have, if I select it here, information on the gene associated, which in this case will be POLG. So this is the overview a little bit of the database. I hope you have seen that you can play with a different type of data depending on the use case you have. And now, before we go for questions and a little bit of discussion, I would just like to show you the third type of approach, which is when, for example, in an analysis platform. So here you are seeing the genome phenome analysis platform, the new interface that we have developed. And once you have identified a causative variant, in this case, example for it would be in the POLG gene, the idea is that thanks to systems like Treatabolome, the geneticists or the clinical researcher or whoever is analyzing the data can quickly go and see if there is a possible treatment associated to this variant. So in this case, I will go here to actionability, and we offer options, different links to databases. If I go to the Treatabolome database, I can see that for POLG, there is this treatment that we're indeed looking into it with our previous use case that has been applied. And from there, I can see the variants that have been associated with the patient that are in this study. And as we said, more information on the effect, clinical effect that is reported there, or comments from the expert, or of course going and linking to the corresponding publications to make a proper decision. So I will leave here the demo. Before going for question, I will just share one final slide on the future development. So let me check. Well, I will keep it like this so I don't have to change the screens. So the future developments that we are envisioning, as Alberto was saying before, and what we have been showing with the integration of our deconic genome phenome analysis platform, is really to enable this programmatic access to all the data, all this data that has been made interoperable, so it can be used for other decision system tools, not within our project, but really to the whole scientific community. Also, we are planning to include new ontologies related to treatment. And for example, there is this MAX ontology that is being developed by Peter Robinson groups in the JAC Institute that will be also very helpful to classify and describe patients and treatment options. And finally, as Alberto was mentioning, we will work on identifying the best approach for this crowdsourcing initiative. So we don't always have to go through systematic literature reviews, which is a lot of work required for the clinician, but we should be able to enable a case by case or upload of the data, and ensuring that this data is entered by experts and really curated. So we also are very happy to get more data in from other type of disorders. And for this, if you are part of another European reference network, if you are interested in the initiative, please contact Giselle Bon or Antonio Atalaya. They will give you more information on that. But the idea is that Treatabolome grows thanks to the expertise of the whole scientific community. And finally, I would like to thank not only the whole Solvardi team, but more specifically the Treatabolome working group, which is led by Giselle Bon and Antonio Atalaya, all the clinicians participating in the systematic literature reviews, because of course, without them, we wouldn't have all this data in such a nice interoperable format. And also the engineering team at the SINAG CRG, led by David Pish and Alberto Corvo, and the team is led by Sergi Beltran. So now, yeah, I think we can go for questions and or discussion if you have ideas maybe on how to continue on that. So I will stop sharing my screen. Yeah. And I think Giselle, Antonio and Sergi are in the call, so can also interrupt to answer the questions. And Sergi, okay, because Sergi is traveling, so I don't know if you, yeah, now you are able to participate.
Yeah, I'm at the airport already, and I was able to follow most of the presentation, so thanks a lot.
Great. So I see there are questions in the chat, I think. I think there is one question from Matis. So I don't know, Matis, if you prefer to just speak, or if you prefer me to read it. I cannot speak. Okay, so I read it. Question is, what is the rate of updating the underlying database? Is there also a central person doing so, or just decentralized? This is group-based ad hoc efforts.
So maybe I can take this one. Or Giselle, I can answer that if you want. Well, I can give a first answer, and then Giselle can also write hers on the chat. So at the time being, Mathis, there is no way or no real scheme for updating the system, except if the group of experts that did the original systematic review doesn't update on this review. And this is why we want to put in a crowdsourcing approach, so that the data which is in can be updated, and that also new data can come in through different approaches, and having to do a full systematic literature review, which we know it's a daunting task, right? Because there's a lot of literature out there that needs to be mined and read. And also to facilitate the process of these systematic literature reviews together with other groups. My group doesn't have expertise on this, but I think Peter Robinson and others have expertise on this. We would like to facilitate making these systematic literature reviews in a way that there's some automatic mining of the literature, so that at least you don't have to go through all the searches yourself and read all the papers or all the abstracts, and that you can really get some starting, let's say, statements automatically from the papers. Then you can, as an expert, validate. So this is some of the projects that we are thinking of doing, but this will need, will take some time. Also, we are looking for additional funding to fund some of these initiatives. So if you're also aware of calls that could be useful for that, that also would be welcome and helpful. So far, I think the other question was who is doing that. So far we have Alberto, who is taking care of both the clients, so the front end, but also the back end, together with other people in my team and David's team, and they are the ones which are taking care of the system. But we are happy to get more people involved on that. Did I answer all the questions, Leslie, from Mathis, or were there any others?
Yeah, yes? I think so. Good. I think Giselle, you can also.
I can complete, and thanks a lot, Sergi, for putting the first part. And of course, so far, what is in the Treatabolome, as you understood, has been made by different experts of the different diseases, and of course, there's experts follow their field, and then could let's say we could decide on a regular basis to ask them to make an update. But obviously, the best way would be using the tools that Sergi just described with crowdsourcing, having a tool that we get all the updates and have the expert once again validating what has been retrieved from the literature. And I would take the opportunity of this answer to say that we have so far 6-7 data sets for different disorders, but as you all know, there is much more than 7 clinical entities as rare diseases, and we are still looking forward for experts who would be keen to initiate such a type of systematic review of the literature of their disease of interest, to feed further this Treatabolome, waiting for the tool, of course, that Sergi's team can develop. But we can go forward in parallel, I would say. And so far, we have been successful with the 7 first data set, and I'm sure we can identify very interested people who would like to promote the treatment available for their specific diseases. Thank you for all the great job for the database.
Thanks, Giselle. I don't see any other question in the chat. Also, if someone wants just to speak, I think if you raise hand, we can give you, Cornelia and Birte can give you access to for speaking. No, otherwise, Giselle, Sergi, I don't know if you wanted to add anything on the general comment.
Yeah, I just wanted to state again, I think you and Albert already mentioned, this is like a first version of the system, the first version that we put in production of the system. It can cover some of the use cases, as Leslie already showed, but we are, besides looking forward to having more data, as Gisela was saying, also we are looking at hearing other use cases and needs and what are the issues that you see with the current system. So we are willing to improve this and make this a system that is useful for the community. So if any of you thinks this might be useful and goes and tests it, and they see that something could be better, or there could be another use case covered, the data could be presented differently, we are all ears. So we would like to hear your opinion on that. And there's the website, you will find a contact email address where you can send your suggestions, and we'll look into those.
And to complement the point of Sergi, of course, as Leslie and Alberto nicely highlight, feel free to contact us with help for any systematic reviews. We could guide you how to proceed, etc. Antonio Atalaya has made a great job there with writing the guide for these purposes. And together with the team of Sergi, we are really keen to help anybody who would like to try to initiate such data set. And I think it's really interesting to work to start. So feel free to contact us, and as Sergi said, to propose any improvement or questions. We are there to improve the tool and to make it available for the largest community as possible, for the largest number of diseases as possible.
Perfect. Thank you, Gisela. I think it was a nice conclusion also.
So then I want to thank the speakers and the panelists and attendees on behalf of the SolveRD coordination, and we will now close the session. So thanks you all and goodbye.